Kefir occupies an interesting position in the probiotic food landscape. It contains a wider diversity of live bacterial and yeast strains than virtually any other commonly consumed fermented food. It has been consumed in Eastern European and Caucasian cultures for centuries with a historical association with longevity. And it is increasingly supported by a body of modern microbiome research that lends scientific credibility to what those traditional cultures appeared to understand intuitively. The gut health conversation around kefir is arguably more substantive than the marketing around most probiotic supplements. The microbial diversity in genuine kefir is considerable. Where yogurt typically contains 2 to 7 bacterial strains, properly fermented kefir contains 10 to 30 or more strains of lactic acid bacteria alongside beneficial yeasts, organisms like Lactobacillus acidophilus, Lactobacillus kefiri, Bifidobacterium bifidum, and various Leuconostoc and Cluiveromyces species. This diversity is significant because gut microbiome research consistently points towards species diversity as a marker of health, and different bacterial strains appear to contribute distinct functions, some producing short-chain fatty acids, others modulating immune activity, others competing directly with pathogenic organisms for intestinal niche space. A cup of milk kefir provides 9 to 11 grams of protein, 20 to 30% of the daily value for calcium, meaningful B12, B2, and phosphorus, and approximately 100 to 160 calories, depending on fat content. The fermentation process reduces lactose content substantially, typically by 30 to 40%, making kefir better tolerated by people with lactose intolerance than regular milk, though it is not lactose-free, and individuals with severe intolerance may still experience symptoms. Water kefir is an alternative for dairy-free populations, though its protein and calcium content are considerably lower. A randomized controlled trial published in a high-profile journal found that fermented food consumption, with kefir specifically included as one of the interventions, increased microbiome diversity and reduced inflammatory marker levels more effectively than a high-fiber diet alone over a 10-week period. This was a well-designed study, and the findings generated significant interest in the microbiome research community. The immune system interactions of kefir are plausible mechanistically and supported by some human trial data. Regular kefir consumption has been associated in controlled studies with reduced incidence and duration of respiratory infections, improved response to rotavirus-induced diarrhea, and reduced allergy symptoms in some atopic populations. These effects are not dramatic pharmaceutical-grade interventions, but they are consistent with what we would expect from regular modulation of the gut immune interface. The primary practical caution is that commercial kefir products vary considerably in the number of live cultures they actually deliver at the time of consumption. Heat treatment after fermentation destroys the organisms, which defeats the purpose. Look for labels that specify live and active cultures and confirm that the product has not been heat-treated post-fermentation. Homemade kefir made from kefir grains is the most reliable way to ensure maximum probiotic activity, though it requires more preparation effort than opening a store-bought bottle.